When working in 3 dimensions, the only real difference is with using Pythagoras or right angled triangles is that you have to visualize those and extract them from the shape. So if we take this first example here, we want to find the distance AB. Here's the right angled triangle relevant to that. Where the dimensions are 7. This is what we're trying to find ultimately. But we don't know this length here. That length, let's just call it y. Now, if we focus on that length there, what we see is we have another right angled triangle on the base of that shape. And if we extract that triangle, it looks something like this, where that's y. That's 8, and that's 10. And of course they are both right angled triangles. So we need to find y, and then substitute that onto that triangle there in order to solve for x. So, y squared equals 8 squared plus 10 squared. Y squared equals 164. Y equals root 164 centimeters. It's an intermediate value. Don't evaluate it. Keep it exact. And then we go on to our second calculation. X squared equals y squared plus 7 squared. That's just 164. That's 49. So x equals root 213 centimeters, and you could evaluate that to get an approximate answer. The nice thing about that is that we can generalize this. So if you have a look at this diagram here, this is a generalization of the previous one. If we want to be able to find that value, then we've got that right angled triangle where this is a shared side with this right angled triangle. And so following a similar process then, we would do x squared plus y squared equals c squared. And we could say that c is equal to the square root of x squared plus y squared. And then for the second triangle, c squared plus z squared equals s squared, where c is the square root of x squared plus y squared. This is equal to x squared plus y squared. And so we have a generalization for Pythagoras' theorem if we're dealing with rectangular prisms or cuboids of any sort. You often get examples with pyramids and cylinders. I'm only going to look at an example with a pyramid here. So we have a right pyramid. That simply means that the vertex of the pyramid is above the center of the base, and it has a slant edge of 80. That is referring to this. That's 80. Excuse my terrible drawing skills. And the perimeter of the base is 160. And we know it's a square base. So 4x would be 160. x is 40 meters. And we have to find the height of the pyramid correct to the nearest centimeter. So, this is what we're trying to find. Vertex directly above the center of the square. So, here's the triangle that includes the slant edge. This is what we're trying to find. We don't know that length. However, if we look at this right-angled triangle, where those two sides are equal, what we do know is that this is 40. And so we could solve this one. Y squared plus y squared equals 40 squared. 2y squared equals 1600. The difference in this question here is this 2 in front of the y squared. So we divide both sides by 2. And y is equal to root 800, of course, disregarding the negative. Don't really care what that's equal to. Keep it as an exact value for now. No need to necessarily simplify that third. Then we're going to go up and do this triangle. H squared plus y squared equals 80 squared. So h squared is equal to the square root of 5600, and h to the nearest centimetre is 74.83 metres. This, of course, being the centimetres place within that solution.